This is where we were in our last video, and looked at calculating this integration, and we got 0 for the answer using direct line integration. But now we're going to repeat the integration using Green's theorem. Alright? The integral is equal to 0. Just make a note of it up here. Alright? Now, if you didn't watch the previous video, you need to do that. And as I said in that video, I want you to try this question yourself. Alright? Now, here, let's redo this using Green's theorem. So let's make a note here. Green's theorem. Now, remember what Green's theorem says, the formula for Green's theorem. Alright? It says that if you have the integral around a closed curve of a function of x and y in the direction x, that's the horizontal component, that's p dx, plus q, which is a function of x and y again in the direction of y dy, this is equal to negative. Now remember, you must always have a negative, because in one case you're going, say for example, from left to right, and to close the curve you go from right back to left. Alright? So you have a negative. It's going to be a double integral, because it's like you're calculating an area. It's a double integral around the region R of. Now you're going to subtract one from the other. Here, it's the, no, let's try to see how you could remember this formula for exam, but hopefully you will get a formula sheet also with it. You're going to have P and then Q, just like how you have the P and Q here. Alright? P is the horizontal component, but you're going to differentiate it with respect to the vertical axis. Right? We're going to see how the horizontal and vertical change. And Q, we differentiate Q. You're going to have derivative of Q with respect to, now the Q is the vertical axis, but you're going to find this change with the horizontal thing there, the horizontal axis, horizontal change. So as P changes horizontally, how is it changing with the vertical? And as Q changes vertically, how is it changing with the horizontal? Alright? So P is horizontal, Y is vertical. Q is vertical, X is horizontal, alright? Alright, so with dx, dy. Remember, you could switch them around to dx, mean you're going to do the inner integral with respect to x, and then dy, the out. After you do the dx integral, then you do the dy integral. You remember your double integration, right? And you see, using Green's theorem lets you practice your double integration. Alright? Now, here, what is P and what is Q? Alright? Now, if you look at the formula for P dx, the integral, P, you can see here, it is x squared plus y squared. So P equals x squared plus y squared. And then you look back at the formula for Q. It's the formula for the vector field. What is Q? Q is 2xy. So Q is 2xy. Alright? Now you want delta P and delta Q. So we rewrite this thing here. The double integral around R of delta P by delta Y minus delta Q by delta X dx dy. What is delta P by delta Y? Delta P by delta Y is equal to, it would be 2y. Alright? Because it's treating x as if it's just a constant. So delta P by delta Y is 2y. So replace this with 2y. Now what is delta Q by delta X here? Well, again, it is 2y. So you replace delta Q by delta X with 2y. Okay. Now, here, you can make a certain argument even before you find out what the boundaries of the integral are, right? For the x, you could say it goes from here to here, from the left to right, and then you have dy, but it would be more convenient to switch them around, right? And do dy first, because to find x you'd have to do your thing there, your transposition. But anyway, what was the argument I'm talking about? If you do a double integral around a region R of 2y minus 2y, you'd say, what is 2y minus 2y? It's 0. Dx dy. But when you do the first integration and you integrate 0, what do you get? You get 0, right? Because when you do the dx part here, it is 0x to the 0. X to the 0 is 1, it's 0 by 1. And then we'll add 1 to 0 to get 1. And you say 1 times 0x to the 1 is 0 just the same. So you can't escape from it. So it is 0. And then when you do the inner integral and you get 0, the outer integral will be the integral of 0 dy, which is again 0. So you see how quickly you finish with Green's theorem in this case. So the first integral was 0, but this is 0. Alright? So, remember, any question and so on you have, place them in the comment section. Alright? So, that's it for now. I'll see you in the next video.